Welcome back, everybody. In this video, we're going to talk about how we create linear functions from word-based scenarios, give you a few tips on how to write functions when we have word-based problems to deal with, everybody's favorite. I've got this handy little checklist of 5 questions that we're going to ask ourselves when we're trying to write a linear function from a word-based scenario. And here are the 5 things. First, what are the 2 variables that are related in the scenario? First, we're going to read through the problem scenario and try and figure out what the 2 unknown variables that appear in the situation are and how they're related. The second thing we're going to consider is which of those 2 variables is the dependent variable. Which variable depends on changes in the other for its own changes? And connected to that, which of the 2 variables is the independent variable? The variable that is changing to cause changes in the dependent variable. The fourth little thing on our checklist, how much does the dependent variable change when the independent variable changes by 1? Now, sometimes this will be obvious for us. Sometimes we might have to do a little bit of work to figure this out. And then the fifth thing we're looking for to write these functions, what's the value of the dependent variable when the independent variable is 0? If we answer all 5 of these questions and can figure out what they are, then we can write a function, and it's very simple. We'll take our dependent variable, that's going to stand alone on the left-hand side of our function, and whatever that value was that we found for the change in dependent variable, okay, this one right here, how much does the dependent variable change when the independent variable changes by 1? And we're going to multiply that by whatever the independent variable is, whatever letter we pick for that. And we're going to add to that the value of the dependent variable when the independent variable is 0. Okay, so those last 2 questions really are telling us the numbers that are going to go into our function, and questions 1, 2, and 3 are really telling us what letters we're using here in our function. Alright, let's go ahead and try this. We'll look here at example number 1. We're going to write a function for this scenario. Victor owns a t-shirt print shop. He charges a $25 flat fee for designing a shirt, and then $16 for each shirt that a customer orders. We're going to write an equation to relate the number of shirts ordered and the customer's cost. So what are our 2 variables in this situation? Well, one variable is the number of shirts that are ordered by a customer. And we want to assign a letter to that. Doesn't really matter what letter we assign to that. Maybe we'll wait a second to assign a letter to that. And the other variable is the customer's cost. We'll assign C for cost and N for the number of shirts ordered. Sounds good to me. Alright, now, once we've identified these 2 variables, we need to decide which one is the dependent variable and which one is the independent variable. Does the number of shirts ordered depend on the cost, or does the cost depend on the number of shirts ordered? And if you think about that for a minute, you'll probably realize that the cost here is the dependent variable. It depends on how many shirts are ordered. So the number of shirts is the independent variable. Okay, so once we've identified those 2 things, we now turn to question number 4 on our list of questions. How much does the dependent variable change when the independent variable changes by 1? So if we order 1 more shirt, how much does the customer's cost increase? If you read through the problem, it says $16 for each shirt. Okay? So that's going to go into our function. And then the other thing we need to know is the value of the dependent variable when the independent variable is 0. What is the cost when the number of shirts ordered is 0? And that's related to this flat fee right here. Okay, so to write our function, we're going to take our dependent variable. That's equal to the change in the independent variable. Pardon me, the change in the dependent variable when the independent changes by 1. So we put 16 in there, times the independent variable, and then add the value of the independent variable when the dependent is variable when the independent is 0. That was 25. And this is a function that represents the cost. And you can kind of check and make sure that this function makes sense. If we put 0 in for the number of shirts, it costs 25. If you pick any number of shirts and put it in there, it should give us the cost for ordering that number of shirts. And so this is going to be our function. Alright, on to example 2 here. We're going to write a function for this scenario. Jacob delivers groceries to people's homes. He charges a fixed rate per mile and also a fixed delivery fee. When Jacob makes a 10-mile trip to deliver groceries, he charges $14. When he makes a 5-mile trip to deliver groceries, he charges $9.50. Write an equation to relate the amount of money in dollars Jacob will charge, so that V there, will charge when he makes a trip of X miles to deliver groceries. So we let X equal the number of miles, since it kind of told us that in the question. And what's the other variable? It's the charge. Maybe since we used X for number of miles, we'll make Y the charge. Now, which depends on which? Does the number of miles that he traveled depend on how much he charges? Or does how much he charges depend on the number of miles he travels? Well, if you think about that for a second, the amount he charges depends on the number of miles that he travels. Okay. Oops. A little technical difficulty there. So when we write our function, it's going to be y equals something times x plus something. Now we need to figure out what those somethings are. We need to figure out how much does the dependent variable, how much does his charge change when the independent variable changes by 1. Well, we don't have an easy way to figure that out from the words that are given to us, but we are told that a 5-mile trip costs $9.50 and a 10-mile trip costs $14. So to find out how much the dependent variable changes when the independent variable changes by 1, we're going to take the differences in those values for the dependent, and we're going to divide it by the difference in the values for the dependent. That's $4.50 divided by 5 miles. Looks like he charges 90 cents per mile. So that's going to go in here. That's how much it changes, how much the dependent variable changes when the independent variable changes by 1. The other scratch work we need to do is we need to figure out what the dependent variable would be when the independent variable was 0. Now this is actually easier than you think in this problem, since we know the change for it in the charge for a difference of 5 miles. To get to a 0-mile trip, we just need to subtract that difference one more time from here. The difference is $4.50. So subtracting that away, we find that his delivery charge was $5. And so we'll put that into our function. Now, the last thing I want to do here is just double check and make sure that based off of the information that I'm given in the problem, that this function does indeed give me the values that are listed there. So if I put 5 miles in here for the distance, it should give me $9.50. And if I put 10 miles in here for the distance, it should give me $14. And my function checks out with both of those, and so I'm pretty happy with the function that I wrote. And those are some tips on how we can write functions from word-based scenarios. See you next time.